Okay, so we have started with doubly linked list, and we have implemented two functions. One is insert at end and the display function. So this is our session 25, and today we'll be implementing the rest of the functions of doubly linked list. And what we did with we are trying to transform the SLL program into DLL program. So we have transformed the insert at end of SLL into insert at end of DLL, and also the display function. Now this is insert at beginning, the second function, and all SLL terms are already replaced with DLL. So just we need to see that at what all places we need to make the changes so that we can convert the insert at beginning function of SLL into a insert at end function of DLL. Okay. So this is when a node has been created, the data has been entered into the data part, and here we have null. So safe programming. Let me set the preview pointer also to null. So this is one additional statement for DLL. Then if h equals null, so h equals p, fine. Else p of next equals to h, and h equals to p. What else we need to do into this? Here we are writing p of next equals to p because we want to make the new node, that is p, as the first node, that is insert at beginning. So we are simply writing p of next equals to p equals to h, and then h equals to p, done. So this is specifically for the SLL. But when you talk about DLL, so every node has got two pointers. One is the next pointer and one is the preview pointer. Okay. So the first node, which is now going to become the second node, that node is also going to have two pointers, the next pointer and the preview pointer. And what we are understanding that when we have the first node, the preview pointer of the first node is pointing to null. But now the first node is going to become the second node, and P is going to become the first node. So that earlier first node, the node which was first node earlier, which is going to become the second node now. So that node preview pointer should point to P, because P is going to become the first node, and that node is going to become the second node. So its preview pointer should point to P. So here, before setting P of next equals to H, yes, no, not before, but after this, I can say H of preview. Now, why I'm saying H of preview? Because H is still pointing to the first node, and I need to make the preview pointer of that first node pointing to P, because now P is going to become the first node. So after this, then we write H equals to P. Done. Absolutely fine. So I can say this is my additional statement. Additional to SLL. And this is also additional to SLL. Now, please keep in mind there are the different way of doing the same thing, no doubt about it. But what we are doing, we are going with a simple way by which we are trying to convert the code of SLL into a code for DLL. Now, let us check. So, yes, insert at beginning. Yes, it is the second option, case 2. So, let us compile our code. Okay, so it got compiled. Let's execute it. It is session 25.exe. Okay, it got executed. So first, let us create few nodes. So I go for insertion. This is by default insert at end. So this is my first node, 10. Then I go for one more insertion. say 20. This is by default at end, so 20 would be added after 10. That is at end. And now if I display it, six option. So our data is 10, the first node, and this is the second node. And remaining is something like a meta information about the list, the next pointer, the pre pointer, and then the addresses of the nodes. So let's go for the second option, insert beginning. And my data is suppose 5. I want to insert this node 5 at the beginning. So this should become the first node. So let's see whether it's happening or not. Let's display the list. And yes, 5 has become our first node. Then 10 is the second node, which was earlier the first node. And then 20 is the last node. And if you check out the addresses, then all addresses should match as per our requirement. So this is the next point of the first node, which should be the address of the second node. So yes, it is the address of the second node. You can see here. And this is the pre pointer of the second node, which should be the address of the first node. So yes, it is an address of the first node. And the pre pointer of the first node is pointing to null. So the address is shown as 0. And the next pointer of the last node is pointing to null. Again, the address is shown as 0. And the size of the list is 72 bytes. Okay. So insert beginning is working fine. I can go for one more time. Insert beginning, and I insert say 1. I display the list, and it is 1, 5, 10, 20. Okay. So the node 1 has become the first node. It has been inserted at the beginning of the list. Okay. So this is done. Now let's see the next function. So insert at beginning is done, and then we have insert after. So this is a function wherein you need to search for the given node first. And if the given node exists, then we need to insert a new node after this given node. Okay. So the search function would be same, or I mean to say the searching code would be same. And a new node has been created here with the help of malloc function. Then we are checking whether the node has been created or not. If the node has been created, then yes, make up the data part. P of data equals to D, then P of next equals to null. This is for safe programming. And again, I say P of prev. This is an additional statement because you got one additional pointer equals to null. Okay. So initial value of the pointers we are setting to null. So they should not dangle out here and there if we miss out setting them properly. So this is initialization of an additional pointer, temp equals to h. We know this part. We know this part while temp not equals to null, and at the same time temp of data not equals to k, temp equals to temp of search. So this is basically for searching, and this is applicable for SLL and DLL both. It is for searching the given node, searching a given node or given key value. One key. Okay. And after this, if the key exists, then TMP would be pointing to that node where the key is present. And if it does not exist, then TMP would be null. So that's why we are just putting a check. If TMP is not null, it means that we have got or we have searched the given key value. And if it is null, then we come to the else part. In the else part, we simply say given key does not exist. Okay. So if it exists, so here we need to come in and into this if block, we need to insert a new node after this given node. So TMP is pointing to a node, and after this given node, we need to insert a new node. Okay. Now, in the last session, I said you about one thumb rule for handling any operation of the assembly language, or handling most of the operations of assembly language. Make and then break. I repeat, make and then break. Okay. So what does it mean? It simply means that you first need to make up a pointer and then only break the pointer. Okay. So practically, I mean to say that if your P is a new node, so make up the pointers of the new node. So P of next, P of prev, and so on, and then break the link. Breaking the link means you are changing the chain. I mean to say you have already a linked list, intact linked list, and then you are inserting something or removing something from it. Okay. So you are trying to make the changes into the link of the list, which is already existing. So we call it as a break. Okay. So a thumb rule is to always make first and then break. So P of next equals to temp of next. Now P is the node which has to be inserted uh, after the node TMP. So P of next equals to temp of next. Yes, absolutely fine. And then what should be P of prev? P of prev. Yes, what should be the value of P of prev? Equals to P of next equals to temp of next. And P is going to be inserted after the given node. The given node is pointed by TMP. Okay. So P of prev should be what? Come on, message into the message part. So there is one, okay, few answers are coming in. So P of prev equals to temp, absolutely right, because P is a node which is going to come after temp. So P of prev equals to temp. Fine, absolutely fine. Now, we have set the pointers of P. I mean to say P of next equals to something, P of prev equals to something. Absolutely fine. We have made the link. Now we need to break up the link. When I say break the link, I simply means to say that the link list is there, which is already a intact link list. Now we need to insert this node in between. Okay, so we are going to break some link or we are going to change some link. Now, while changing the links of the list, we need to ensure that we do not make any mistake which will end up destroying our list. Okay, so that way we need to take an extra care that we are modifying all the required pointers properly. I repeat, we are modifying all the required pointers properly. Now, in doubly linked list, you need to always remember that every node is going to have two pointers, the next and the prev. And likewise, you need to modify the pointers. I repeat, likewise, you need to modify the pointers. Now, the way I am saying temp of next equals to P. Now, please try to understand. The way I am saying temp of next equals to P, in the same way, I need to change a prev pointer of some node to bring this new node in between. Okay. It's a doubly linked list. So if temp of next is pointing to this node, then there should be a node whose prev pointer should also be pointing to this node. Okay. And which node that should be? Which node's prev pointer should be pointing to P? Come on, fast. Give your answer into the chat box. I repeat, which node's prev pointer should be pointing to P if I want to bring P into this list? I want to insert P after temp. Okay. So which node's prev pointer should be pointing to P? Then only I can say, okay, P is now properly inserted. Yes, temp of next. Absolutely right. Temp of next prev pointer should be pointing to P. I repeat, a node which is next to temp, that node's prev pointer should be pointing to P. A node which is next to temp, that node's prev pointer should be pointing to P. Okay. What I mean to say, let me try to write it over here. There's a list, dot, dot, dots. Already some nodes are there. And there's a prev pointer of my temp pointer. And this is my temp. So this is my temp node, you can say, a node which is pointed by temp. And then the temp node has a next pointer also. So, and then suppose there is some node, let me call it, say, Q. Okay. So Q has got its own preview pointer, which is pointing to temp. Let me call it Q. And then it has some next pointer, and then suppose dot, dot, dot. Okay. So this way, I am just trying to visualize you. I'm just trying to make you visualize that this is our doubly linked list. There is a temp pointer which is pointing to a node which has the key value, and there is a node after the temp node, that is a Q node. Now, according to our understanding, the node P, this new node, should come in between this. Okay, what we need to do? We need to insert P after temp. So P should come here. Okay, we need to insert, this is insert after. So the new node P should be after temp. Fine. Now, when new node P should be after temp, there will be a pre-pointer of P and there will be a next pointer of P. Okay. If you see carefully, then we have already set P of next equals to temp of next. The moment we have set P of next equals to temp of next, earlier temp of next was pointing to Q. Okay. Let me remove it from here. This is still not into my, you can say, list. And here, when I say P of next, so the next point of P has started pointing to temp of next. What is temp of next? Temp of next is pointing to a node Q. So P of next becomes Q. Okay. And then we say P of prev is temp. So when I say P of prev is temp, so I mean to say this prev pointer, previous pointer of P is pointing to temp. So here comes my temp. Are you getting it? So temp is now set to the previous pointer of P, and Q is set to the next pointer of P. Okay, according to this. Now the pointers of P have been set properly. So P of prev is pointing to temp, and P of next is pointing to Q. Okay. So now P is ready. Now we need to change this list so that P comes in between temp and Q. P comes in between temp and Q. For that, what we are writing? We are writing temp of next equals to P. The moment you write temp of next equals to P, so your P comes here. But then the rest of the list, which is after P of next is temp of next. So P of next is pointing to temp of next. Yes, P of next is pointing to Q. But, and this is also, prev of P is also pointing to temp. But this Q of prev is not pointing to P. Q of prev is not pointing to P. So we need to access this node so that its prev pointer should be pointing to P. Then only P would come in between. Otherwise, P will not come in between these two nodes. Okay, that we need to understand. Now, for that, when we write temp of next equals to P, before this, I need to access the Q node, which is after temp, How I can access that? Simply by writing temp of next. The node Q is after temp of next. Okay, the node Q is after temp. So I write temp of next. So when I write temp of next, I access the node Q. What I need the previous pointer of node Q. I need a previous pointer of node Q. Now, please see here carefully. In pointers, cascading is allowed. The way we are implementing the linked list, cascading is allowed. Now, what does it mean? It simply means that when I write temp of next, So I am getting the next pointer of 10. So in short, I can say I am getting the next node of 10. I repeat, I am getting the next node of 10. And then I can set it prev pointer, temp of prev equals to P. This is called cascading. See here carefully. Temp of next will give me the node Q, and then I want its prev pointer to be set to P. That's why I'm writing temp of next of as operator prev equals to P. And then I can simply say temp of next equals to P. Okay. Is it understood? Any doubt into this? Please let me know if there is any doubt. Okay, good. Now, can you tell me that whether I need to put this under some condition? What I mean to say that is there any possibility that this statement may fail? Is there any possibility that this statement may fail or this statement may lead to the condition which is not expected? Okay, let me show you programmatically or let me show you practically that when does this statement fail or when would this statement fail. So let us done. I think it is done. So now let us compile this code. The code may be running already. Yes. Let me restart. Please remind me to show if I fail, if I forget to show you when the code would be failing. So please remind me to show that part. So I will put up one condition. I will create one situation or scenario wherein that code would fail. Okay, so it got compiled. Let's execute the executable. Let's execute few nodes. Sorry, let's insert few nodes. So say 10 and then insert one more 20. Fine. Let me display the list 10 and 20. Yes. Then insert after. Let me insert few more nodes. Say 30. 3 nodes are there. And now let us go for insert after, the third option. And first I will try to insert a new node after 20. Okay. So let's see that. And I want to insert 25. So my data is 25 and my key is 20. Let us display. So yes, 25 got inserted after 20 perfectly. All things are proper. Now let us insert a node after the first node. Okay. So the first scenario was inserting a node after the intermediate node. Second scenario is inserting a node after first node. So let us check for the second scenario. The third option, insert after. My data is suppose 15 and I want to insert it after the first node, which is 10. Let's display. And yes, it got inserted 10, then we have 15, then 20, 25, 30. Let's check for the last situation. First situation was after any intermediate node. Second situation was after the first node. And then I want to check for the last situation, which is after the last node. Okay. I want to insert a node after the last node. Then obviously there would be one situation where the key element should not be a part of the list. Let me first check for that. So I want to say insert 40 and I want to insert it after 50, which does not exist. So we should get an error message. Yes, given key data does not exist. So we are getting this. Now I want to insert after the last node. The last node is 30. So insert after, third option, and I want to insert 35, and I want to insert it after 30. So my key element does exist. Oh, it's stuck and stopped. So yes, the code failed. The code failed for a situation or a scenario where we wanted to insert after the last node. So coming back to that point, again the same question, whether this is to be done conditionally. Temp of next of prev equals to p. Whether this is to be done conditionally. Yes, it has to be done conditionally. When you say temp of next of prev equals to p, now try to understand that you got a scenario wherein you are inserting a node after the last node, for which we have seen that the code is breaking. Okay, so in that case, your given node is the last node. So TMP is pointing to the last node. Okay, in that specific example, it was 30. So my TMP was pointing to the last node 30. Now, when I try to execute this statement, temp of next. So temp is pointing to the last node, and temp of next is what? Null. So now what we are trying to do, null of prev equals to p, which is invalid statement. Null of prev equals to p, which is an absolutely invalid statement. We will be thrown out by the operating system. Our code is aborted by the operating system. Okay, so this we need to understand that this is something like a very undesired operation in case of pointer. So we can make it a very safe code by executing this statement only if it is not the last statement. If it is not the last node, the node after which you are inserting, if that node is the last node, then this statement should not be executed. Okay, so I simply mean to say if the given node 10 is not the last node. So how I can find that? If temp of next is not equals to null. If that is the scenario, then only make the next node prev pointer as p. Otherwise, there is no next node, so there is no logic of making or setting its prev pointer to p. Let's save this code. Let me compile. It should say code is running. Yes. Let me restart. Okay. I compile my code. On compiled. Let's execute and let's check for that condition. I insert one node, say 10. I insert one more node, say 20. I display my list 10 and 20. And now insert after the last node. So insert after third option, and I want to insert 25, and I want to insert it after the last node, which is 20. Okay, so it did not break, and let's see whether it is displaying it properly or not. So yes, it is getting displayed properly, 10, 20, and 25. Okay, so now our code is working properly. So fine, insert at end done, insert at beginning done, insert after done, display is already done, and then remove last. We can start with the remove functions. So this is remove last. By default, it is to remove the last node of the list. The logic would remain same. You need to reach to the. In fact, you need not have to go for this additional pointer prev. Okay, If you remember, how did we use the cascading temp of next of preview? Likewise, you can say temp of preview of next, or you can say temp of preview of preview. So that way you can, directly jump one node ahead or one node before with the help of this additional pointer preview. So basically, when we are talking about DLL, so if you want to access the second last node, you need not want to make use of this preview pointer, which we did for SLS. Why? Because you already have preview pointer in the node itself. So you move to the last node and then you access its preview pointer to access the or to get the second last node. Okay. So that was quite straightforward and easy, and it is highly recommended to do it that way. Then only we are basically exploiting the DLL. Otherwise, it doesn't make sense. So I will avoid using this additional pointer, and I remove all this stuff. I don't need this. I don't need this. So basically, I can simply remove this. Fine. That's fine. So now temp is pointing to the last node after this while loop. And here I am saying that if this node is the last node, sorry, if this node is the only node in the list which we are removing, then it's simply h equals to null. Absolutely fine. Else, uh, preview of next equals to null. What do we need to write here? I need to access temp is pointing to my last node, and I need to access the second last node. What should I write? Come on, it is quite straightforward. Tell me fast. I need to access the second last node. Temp is pointing to the last node. I need an access to the second last node. What should I write? Please give your answer into the chat box. Temp is pointing to the last node. I need an access to a second last node, and this is doubly linked list. So temp is the last node. Temp of next is null. What is temp of preview? Temp of preview is pointing to the second last node. Okay. So temp of preview is pointing to the second last node. So I can simply write here temp of preview. Okay. And with the help of cascading, I can write temp of preview means the second last node and its next pointer equals to null. So this is nothing but the next pointer of the second last node. Temp is pointing to the last node. So next pointer of the second last node is set to null. Okay. And then after this, you can make temp of next equals to null, temp of free equals to null, and then free temp. Or you can simply free temp. No issue. Now, the way we are writing temp of preview of next equals to null, basically this parentheses are not required. But just for the sake of proper understanding, I am putting it. So without parentheses also it will work as it is. So this is just for your better understanding. So this way we will be reviewing the last node. Okay, I think it is done from our side. So let's save the code. Let's recompile it. I need to close it. This is an additional task every time we need to do, unfortunately. It would be a good help if someone of you find out a solution for this or any shortcut for this. I don't like every time restarting the Visual Code Editor. So remove last. So let us insert few nodes, 10 and 20, and my list is 10, 20, and I go for the fourth option, remove last. Let's see. It says last node removed. Let us see. Yes, 20 has been removed, and now we have only 10 into our list. Let me remove that also. Last node removed. Let us see the list. Okay, so linked list is empty, absolutely fine. And if I try to remove from a empty list, yes, it says new list is empty. Fine. So your remove last function is also working. Easily got converted. And after the remove last, we have remove the given node. Now a node is given to us. Again, the same searching operation. And for searching, always remember SLL and DLL. Temp equals to H, while temp not equals to null. At the same time, temp of data not equals to K. Temp equals to temp of next. A very simple and efficient code. And that temp not equals to null is required so that it should not have a pointer problem, because when your list gets exhausted, when your entire list got searched, so again it try to access the data part of the null pointer, which is invalid statement. And that's why before temp of data not equals to k, we are writing temp not equals to null. Okay, so if the first condition is false, then it won't check for the second condition, because this is an AND operator. So since this is an AND operator, if the first condition fails, there's no logic of checking for the second condition. And this is removing the given. And in this also, we do not need an additional pointer. Now, this can be an interesting stuff, wherein we need to remove the given node. So you may need to access a node before the given node. You may need to access the node after the given node. So now that becomes interesting. So let us remove this additional pointer preview. And this is not required. I can remove this also. Okay, then if time equals to null, then the given node does not exist. Absolutely fine. If time equals to h, so this is like removing the first node. So h equals to h of next. Now here what's happening? We are modifying the header. So h equals to h of next. But at the same time, now you need to modify the previous pointer of this new first node. I repeat, new first node, because the given node is the first node. When you'll be coming into this point, or at this point, if h equals to temp, this is only when the given node is the first node. Okay, given node is the first node. Or you need to remove the first node. For example, this is as good as removing the first node. So you want to remove the first node, or the given node is the first node. So in that case, what we are doing, h equals to h of next. That is fine. But at the same time, your first node has to be removed, and then your second node preview pointer should be set to null. Otherwise, it would be dangling, because we are going to remove the first node. Okay. So the second node, which is going to now become the first node, because we are writing temp equals to temp of next. So sorry, h equals to h of next. So h is going to point to this second node, and now we need to set the preview pointer of this second node as null. So I need to simply write here h of preview equals to null. Fine. And this if has got two statements, so we need to enclose them into parentheses. Oh, sorry, curly braces. Else, if the given node is not the first node, then if the given node is not the first node, then it can be any node, any intermediate node, or it can be a last node also. Okay, which you are going to remove now. Since you are going to remove this node, this is DLL. So apart from checking whether the given node is the first node, you also need to check whether the given node is the last node or the intermediate node. The way we did it uh, uh, for the, I think, insert after. Yes. So what I mean to say that if the node which is going to get deleted is the last node, so there is nothing after that node. So we need not have to change the preview pointer of that node. Okay. Let me write here clearly. Then you'll be understanding. Here it is written preview of next equals to temp of next. So basically we need to write here temp of preview because temp is the node which I need to remove. So I would be saying temp of preview, the node which is previous to temp, its next pointer should be pointing to temp of next. Yes. So temp of preview of next equals to temp of next, and temp of preview of next equals to temp of next, and temp of next preview should be temp of preview. Please see here carefully. What I'm writing, temp is the node which I need to remove. So I am accessing a node which is after temp. Okay. So temp of next of preview means the preview pointer of the node which is next to temp should be set to a node which is previous to temp. So that now the temp can be removed. Okay. So temp of next of preview equals to temp of preview. Please see here carefully. Do not get confused. And better if you tell me that where I need to put up a condition for the last node. And then after this, I can simply write temp of next equals to null, temp of free equals to null, and then free temp. Okay. Or we can directly free temp. But before that, what we have done, we have changed two pointers. Please try to understand. Temp is a node which has to be removed. So there may be a node or there is a node before the temp because temp is not the first node. We have already checked it. So there is a node before the temp, okay, or previous to temp. So what we need to do, we need to bring it out, the temp node. So the node which is previous to temp, that is temp of preview, of next equals to temp of next. That's what we have written over here. So temp of preview means the node which is previous to temp. Its next pointer should be pointing to a node which is after temp. So temp of preview. So I access this node, previous node. Its temp pointer, its next pointer should be equal to next of temp. Okay. So that's why temp of preview of next equals to temp of next. Okay. And then there can be a node after temp. So we need to change its preview pointer. So temp of next of preview, that is the preview pointer of the temp of next, should be sent to temp of preview. Okay. So temp of next of preview equals to temp of preview. Now you need to tell me that where I need to put up that last node condition. There is no node after the last node. There is no node after the last node. So this statement should be a conditional statement. So where I need to put up that condition. Obviously, I need to put up that condition over here. If temp of next not equals to null. So if temp of next not equals to null, then only we will be doing this part. Okay. And I can, or I should put it up or safe side into the else part, and then I can free text. Again, there can be a little different way of implementing same, no doubt about it. But this is how we are modifying the existing code of SLL into DLL. Let me save it, and this is removing the given node. So let me check remove given option is there or not properly. The fifth option, yes, it is there. Remove given. Fine. Let me compile it. Code is running. The pointer cascading may look little tricky or little difficult at the first sight, but if you just even practice it on paper, you'll definitely understand it. There's no big deal into that. So let's execute it and let's go for a few insertions. So let me insert data 10, one more insertion 20, one more insertion say 30. We'll check for all the conditions, remove given. So fifth option, and let me give a node which does not exist 40. So the given node does not exist. Okay, so that condition is working properly. Now I did not show you the list. So let me display the list. 10, 20, 30, three nodes are there. Go for the fifth option, remove given. And let us try to first remove mm, the intermediate node, that is 20. 20. Given node removed, it says, let us display. So yes, 20 has been removed, and then we have 10 and 30. And now let me remove a node, a first node, that is 10. So remove given, fifth option, and the key value is 10. It says given node removed. Let us see. So yes, the given node has been removed, and we have only one node. So this one node is itself the first node and the last node. Now let us try this also, and then we can go for a separate check for the last node. Remove given, and let me give 30. Stuck. I was having a doubt. So remove given is not handling a case where you have only single node. That is unfortunate. We should have done that. So basically, it shall come into this part because that itself the first node. So then we are writing temp of next equals to h equals to h of next, which is null. Absolutely fine. But now we are trying to do h of prev equals to null, and which is not good. And basically, what we need to do that we are modifying h equals to h of next, and then h of prev equals to null only if my h is not null, obviously. So if my h is not null, then only I would be doing this. Fine. So yes, now it should work. Again, the code is already running. I need to stop this. So I would be inserting first only one node and display it. So yes, let us try to remove this single node, remove given, and the key value is 10. Given node removed. Let us check the list. Linked list is empty. Absolutely fine. Now let's insert few nodes, 10, 20, and say one more node, 30. List 10, 20, 30. Remove given, and now we'll be checking for the last node, that is 30. It says given node removed. Let's check. Yes, it has been removed. So now your remove given function is also working for all the conditions. It is working if your given node does not exist, if the given node is the first node, if the given node is any intermediate node, or the given node is the last node, or the given node is the only node. Okay. So in all these conditions, it works. Remove given, then you have display, and then you have exit. So are we done with all? I think after remove given, we have remove before. Yes, we have this one function remove before the given node, or removing a node before the given node. Now for SLL, it got little tricky because it was something like we need to made use of the preview pointer, then again traversing because we wanted to remove the node which is before the given node. So it was quite difficult for us. But for DLL, it shouldn't be a big deal because every node has got two pointers. So with the help of that additional pointer, we can or we should be in a position to resolve it easily. So I remove this additional code. Huh? If time is h, then no node before the first node. Okay. If temp is null, given node does not exist. Absolutely fine. And we come at this point only if the given node exists. Okay. So here what we did, we traversed the list again because it was SLL, and we wanted to reach to the node which was previous to the previous node of the given node. But in case of Doubly English, we did not have to do all this stuff, and I can simply get rid of this traversing. And if I want this temp to point to a node which is preview to the preview of temp, let's not do that first. Let's see what it's trying to say. If temp equals to preview, then h equals to h of next. So this is a point where the given node is the second node, and you need to remove the you need to remove the first node. Okay, so this is that case. So in this case, we want to just come to know whether the given node is the second node, if I'm not wrong. So basically, I can check that with something like this. If temp equals h of next, h is pointing to my first node, and yes, h is pointing to my first node, and if temp is my second node, temp equals given node is second node. And so you need to remove the first node. And since you need to remove the first node, so you are writing h equals to h of next. But when you write h equals to h of next, this is doubly linked list, and you need to set two pointers. And again, when you set another pointer, uh, that is your preview pointer, so you should be writing like this. I need to set the preview pointer of this first node because this was the second node, which is now becoming the first node, or which has now become the first node. So we are setting its preview pointer to null. Now you may say that this should be done conditionally as we did in the earlier function, but that condition is not required here because uh, because the node which we are going to remove is the first node. So basically, temp equals to temp of next, and that that condition was required if there was only one node in the list, if you remember. Okay. So in that case, we thought we needed to write h not equals to null after making h equals to h of next. But that condition will not come over here because this is removing a node before the given node. And if there is only one node in a list, then there is nothing before the given node. And there is nothing after the given node because there is only one node. Okay. So if there is only one node, so we will not come into this if statement itself. So we need not have to worry for that case. Okay. So if my given node is the second node, so I need to remove the first node. So accordingly, we have modified the h pointer. Else, if the node which we need to remove is not the first node, it is as simple as that. In that case, what we will be doing? Temp is pointing to the given node, and you need to remove a node before the given node. Okay. Let me just even this, and what we'll be writing into the else part. Obviously, else part would be of multiple statements. So what we'll be writing into the else part? Come on, please. Send me some guesses. You can post your answer over here. What we need to write into the else part? Temp is pointing to a node, and we need to remove a node before this node, which is pointed by temp. So in short, we need to remove temp of preview. I repeat, we are going to remove temp of preview. Okay. So which all nodes we are going to modify? Come on. Please send your answer. I need to remove a node which is previous to temp, which is before temp. Am I audible clearly? Yes, if I am audible clearly, then please let me know. What statement should I write here? Chalo fast. Temp is pointing to a given node, and you need to remove a node before the given node. So basically, you are going to remove temp of preview. That is the node which you are going to remove. So what you need to write here? Anna says temp of preview equals to temp of preview, uh, or temp of preview equals to temp of preview is the node which has to be removed. Temp is pointing to a node, that is the given node, and temp of preview is the node which has to be removed. Now, since temp of preview is the node which has to be removed, so we need to access a node which is even previous to this node, which is even previous to this node. Okay. So if that is the case, so I would be writing here of preview. See here carefully what we are getting. We are getting a node. Temp of preview is the node which I want to remove, and temp of preview is the node which is previous to a node which is previous to temp. Temp of preview is a node which is just before temp, and its previous is this node which is previous to previous of temp. What I need to say that this node next pointer, I repeat, this node next pointer now should be pointing to temp, should be pointing to temp. This is little extra cascading, sorry, equals to the given node temp. Okay. And then temp of sleeve equals to what? Temp of sleeve equals to what? Yes. Temp of sleeve equals to temp of sleeve of sleeve. Okay. Now, what's happening that with all this, uh, we have lost the node which we wanted to delete, and we need to free that node. Okay. Otherwise, वो भटकती आत्मा वाला काम हो जाएगा. So after these two statements, we are losing the node which we wanted to delete. That is temp of sleeve, because we are changing temp of sleeve. The moment you change temp of sleeve, so we have lost that node. Okay. And so before this, since I need to remove it properly, what I would be doing, I need to have it somewhere. So let me get some additional pointers at P, and I can have that. No, not here. So P equals to, sorry, let me write that over here. That additional pointer P equals to temp of this. Now, this is the node which I need to delete. This P is the node which we are going to delete. Okay. So, and this statement then can be changed to P equals to H. And the same thing. So, P is the node which we are going to delete. And if that is the case, so we can simplify this entire two statement. Now, see here carefully how we can simplify it. P is temp of sleeve. So this is my temp of sleeve. Okay. This is my temp of sleeve. So this temp of sleeve can be written as P. So now this becomes P of sleeve of next equals to temp. Okay. And then likewise, this is my temp of sleeve. I need to modify temp of sleeve only. So temp of sleeve equals to temp of sleeve of sleeve. Basically, I can refer this as P. Okay? P of sleeve. Okay. So P is the node which has to be deleted. So P of sleeve of next equals to temp directly, and then temp of sleeve equals to P of sleeve. Temp of sleeve equals to P of sleeve. Okay. So this way, now we are removing the node P from the list, and then here I need to write free P. Here you can check if the given node is the last node. Do you need to play with something? If the given node is the last node, no, because that will take care. So I think that is enough. I just need to declare this additional pointer P over here. That additional pointer is to simplify. And basically, at the end, we need to free that node. That's why we are making use of that additional pointer P. I don't need this. Let's close it, open it again. Let's compile our code. Okay, it got compiled. Execute the executable, and there is no option for remove before. Not see that. Remove before. Have the option of remove given. Let me create that option. On a new line, our sixth option is remove before. And then so this becomes 7, and exit becomes 8. So this becomes my 7th option. This becomes our 8th option. And remove before, that is as good as remove given. I just copy this entire case, paste it over here, and make it case 6. And, enter the key value. And I need to just call my before function. Done. Okay. Again, I need to restart it. Compile my code. Got compiled. Execute. And now you got total 8 options. So we have removed before. Let's insert few nodes. So 10, and then 20, then one more, say 30. Check all the conditions, and let me display 7th option. 10, 20, 30, 3 nodes are there. Then remove before. So first of all, we'll try remove before for a value which does not exist. So I go for 40, and then it says given node does not exist. So yes. So this case is working, and then I go for remove before, and I give the value of the first node. So there is no node before the first node, so it should give us a message like that. So yes, it says there is no node before the first node. So that is also working. So now what we can do, we can remove a node before the 20 and before 30. Okay. So let us remove a node before the 20, which is which happens to be the first node. So I want to remove a node before 20. Let us try that. So I go for the sixth option, remove before, and my key value is 20. And let us display now. So yes, it has removed the first node. So now the first node has become 20. The second node is 30. And now let me now insert. So I insert now 40. Let us display. It is 20, 30, 40. And let me insert one more. I want to select all the conditions. 50, 7. Okay, so this is my list 10, 20, 30, 40, 50. And I want to remove a node before 40. So I want to remove 30. Now 30 is an intermediate node. And that's why I inserted few more nodes to check whether it is removing the intermediate node properly or not. Okay, so my key value now should be 40. So this 30, which is an intermediate node, should be removed properly. So our option is 6, remove before, and my key value is 40. Let's see, 7, and yes, it has removed 30 successfully. So now our list is 20, 40, 50. Now let's give it the last node 50. So I want to remove 40, which is before 50. So my key value becomes 50. So remove before, sixth option, and my key value is 50. Let's see, 40 should be removed. And yes, 40 has been removed, and now we got 20 and 50. Now let me remove before 50, the sixth option. And my key value is 50. 20 should be removed, and 50 should be the only node. So yes, 50 is the only node. And now let us try to remove this node. Now, the condition which I was talking about uh, when which we put inside that if block for h, that is h of prev equals to null. Okay, so we did not put that statement under a condition if h not equals to null, as we did in the as we did in the earlier function, because this that condition is not applicable for this. This is the move before function. So when I say remove before, and if there is only one node, so there is nothing before that node. Okay, so let us try. I go for the sixth option and I say 50. So yes, we get a proper message. No node before the first node, because 50 itself the first node. It is also the last node because it is the only node. Okay, so the before function is also working for all the cases, and this way we are done with the implementation of DLL, Doubly English, and now you have all the functions of Doubly English over here. And one beauty about Doubly English is that you can very easily display the Doubly English in reverse order with the help of pre pointer. Okay, so generally we display the list. If you see the display function, so we display the list from the first node. So from the first node we go to the last node. But since this is Double English and you have preview pointer, so you can start from the last node, and with the help of preview pointer, you can get back. Okay. So for that, first you need to traverse and go to the last node, and then you need to come back from the last node to the first node. And when you are coming back from last node to the first node, you need to keep on displaying the data. So that way you will be reversing the list in a reverse. Sorry, you will be displaying the list in a reverse order. I repeat, you will be displaying the list content in the reverse order for DLL. What do you need to do? Traverse the list, go to the last node, From the last node, come back. Okay. So for example, your TMP is pointing to the last node, for example. So then you can put up a loop while TMP not equals to H because you want to come back to the first node. Okay. So while TMP not equals to H, inside the while loop, first statement is your printf, percentage %d, temp of data, and then temp equals to temp of prev. Temp equals to temp of prev. Okay, not next. So temp equals to temp of prev should be your second statement, your loop close. Done. That's all. Okay. So you are moving in a reverse direction. So you start from the last node and your statement inside the while loop would be first printf and then second should be temp equals to temp of prev and not temp equals to temp of next because you are coming back. Okay, and your condition becomes while temp not equals to null. So that way you can display the doubly linked list content in a reverse order. I repeat, you can display the doubly linked list content in a reverse order. Okay, so this is the implementation of DLL. Any query into this? If you have any query or if you want any function to be implemented for DLL apart from all these functions which we have implemented, then we can do that. Yes, please post your query or your request for the implementation of any other function related to DLL into a chat box. Or you can unmute your mic and you can ask a query. Yes, we are open for the query or we are open for the QA session, question answer. You can unmute. We can do this for next 2-3 minutes. If you do not unmute, then I can call up any student. Who should I call? Okay, Daniel, please unmute your mic.
Hello.
Daniel,
Yes, sir.
are you there, Daniel? Please unmute your mic.
Hello, sir. Can you hear me?
He is speaking, but I am not able to hear. How come? Just a minute. Hello, am I audible?
Yes.
Now you are also audible. Yes, Daniel, can you come back, please?
It's sir.
Uh, no query from your side?
No, sir. No. I am a
So
student.
let me ask something. Okay, so there is already a query. So the query is how can we sort the DLL? Any answer from your side, Daniel, for this query? How can you sort a DLL? Yes, you can unmute. You can unmute your mic and you can say.
No
Absolutely
idea.
fine. No idea. Oh, oh.
Let me think and then I can.
Any other student who can put some light on this? How can you sort a DLL? Yes, any other student, please come on, start discussion. This way only we all can improve. You can unmute your mic and you can say. Yes, no answer. I can call up Ansari Salim. If you cannot unmute your mic, then you can post your answer into the chat box. How a DLL can be sorted. Or Khan Fadhan. Can you tell? I'm calling up few names. Any student who knows the answer for this or any idea can tell me. Mapadi Simran, we can just compare and change the next and view of structure maybe. That was one of the answers. The names which I am calling out, they should answer me. They should at least unmute their mic and say if they know the answer or do not know. But they should respond. I call out few names. I do not remember which all names I called out. But I called out Mapari Simran, then I called out Salim and Farhan. You should unmute your mic and respond me. Even if you do not know, you should say I do not know. Etesham, any idea on this? Okay, chalo. Let me answer. Now, for sorting, mm, no doubt you need to make use of a sorting algorithm. Either you can make use of bubble sort or selection sort, whichever sorting algorithm you want to make use of. But then there are two possibilities how to sort. Okay, the first thing is you can swap the values of the node. I repeat, you can swap the values of the node. Okay. Second possibility, you can play with the pointers. You can play with the pointers. Okay. I repeat, there are two possibilities. First, you can swap up the values. Okay. So in that case, you need not have to change the pointers because you are swapping the node values. You are changing the first node value with the second node and so on. So you are swapping the data of the nodes. Okay. So there you did not have to change the pointer. Second possibility, you do not change or do you do not swap the node values or the node data, but in that case, then you need to change the pointers. You need to restructure your list in such a way that all the nodes are either in the ascending order or in the descending order of their data, okay, of their values. Fine. So this way you can sort a linked list. That list can be SLL, that list can be CLL, or that list can be DLL. You talk about any linked list. If you talk about sorting a linked list, then there are two ways. First, you can swap the values or the data of the nodes. This way you can sort the list. So there you did not have to play with the pointers. There you did not have to change the pointers. Second possibility, which is quite tricky because there you are changing the pointers. There you are playing with the pointers. Okay, so that is quite tricky. So the second possibility is playing with the pointers or changing the pointers. Okay. Now the second possibility, which is quite tricky, is basically the expected way of doing it. You know why? Because your list can consist of not always a basic integer value. So your node can consist of data which can be a student data, which can be any entity's data. What we already see is from only explanation point of view that the node has only a integer data part. Okay, but it can have any type of data. It can have a structure itself. So there you, for example, you have the list of students, and then you need to sort the list in the say ascending order of their marks, or descending order of their marks, or ascending order of their roll numbers, and so on. So there are different possibilities of arranging the nodes. Fine. So in that case, you cannot swap the data because the data itself is called huge data. It has roll number, it has name, it has class, it has marks, it has address, and so on. Okay. So in that case, the feasible option is to play with the pointers, is to change the position of the nodes themselves. Okay. So that way you can better sort the list. So there are two possibilities or two ways. One is by swapping the data, and this is applicable when your node has a very basic type of data like integer, only integer. So that way you can swap the data of the nodes and you can sort the list. Second possibility, which is quite general, is uh, changing the node positions so that they come into the order, in some order. Fine. And for that, you need to change the pointers. The first node may become the last node. The second node may become the first node. The third node may become the second last node, and so on. Obviously, depending upon the condition in which we are sorting. And then finally, you need to make use of a sorting algorithm because the way we are comparing, that is, the algorithm would remain same. Okay. Once the condition satisfies, then for sorting an array, what do? We swap the values. So here also when the condition satisfies, you can swap the data of the nodes if the data is a basic type of data, or in the second way of doing it, you can change the pointers. You can change the pointers. But changing the pointers is little tricky, which you need to do it properly. But once you do that, then you can do it for any type of list. So the second way of sorting the list is a generalized approach, and it is a better approach because irrespective of what kind of data you have in the node, you can sort the list. Okay, so I hope you understand what I am saying, and basically you can try it out. In fact, I suggest you make use of a basic sorting algorithm, say a bubble sort. Yes, go ahead with the bubble sort and sort. Uh, Sorting a DLL is easier than sorting your SLL. You know why? Because it has both the pointers. In SLL, it would be little difficult because every time then you need to go, every time you need to traverse and access the node. So it becomes quite difficult in case of SLL, but it would be little easier as in case of DLL. So I suggest you to sort a DLL using a basic sorting algorithm, and in fact you can have that function in this itself. Okay, so in this program itself, you can put up one sort function, say bubble sort, and you make use of the logic of the bubble sort, and you sort the DLL, given DLL, and you do not sort it by swapping the values. Instead you sort it by changing the pointers. Okay, so that can be an assignment to you people. That's a good question. So after this remove before, you can have one more function which you need to define. And since your list is changing, entire list is changing, of course, then you will be having the return type as your DLL pointer. And this is my bubble sort, so I call it B sort. And it will obviously accept the list to be sorted. So struct DLL star H, and then comes your coding part. So you do this coding part. Okay. So this way, then your function also has got your program has got the sort function, and then you can have one option to sort. You call your sort function in that option and get your list sorted. Okay. So please do that. That's a good exercise. So we stop today's session here.